Now we talk about vectors. A vector is a directed line segment. It has a head and has a tail. Normally with capital letters, I tend to use the letters P and Q as universal typically, or we could name this using one letter. They use the letter V. Or you can bold it. You can put V real dark. You can call it vector PQ, from head to tail, or you can call it vector V. Now, the distance from head to tail is called the magnitude. You can have like two absolute value bars around this. Some textbooks they have one absolute value bar around. It just depends on the notation. It's kind of like absolute value, kind of like the distance from one end to the other. So it's a distance formula. So if you take 2 points, x1 and y1, and x2, y2, you take the second x minus the first x and square it, second y minus the first y and square it. Essentially how that works. So you take if you take 2 points and you want the magnitude of PQ, which is Q being the head, P being the tail. The first letter is the head, second letter is the tail. Negative 3 minus 6, 2 minus negative 1. That's 3 squared is 9. Negative 9 squared is 81. That's 90. But 90 is 9 times 10, so the square root of 9 is 3. This is just simplifying the radical like you would in college algebra. So that's 3 squared root of 10. And then here, second x, 2 minus the first x, 5. Second y, negative 2, first y, 2, so negative 2 minus 2. 2 minus 5 is negative 3. Negative 3 squared is 9. Negative 2 minus 2 is negative 4. Negative 4 squared is 16. This becomes the square root of 25 or just 5. So that's the magnitude of that vector. Now what we typically like to do, we like to put everything in standard form, or we like to standardize everything, which is called component form. So we subtract the x's and we subtract the y. So we figure out what's the distance of the x's and what's the distance of the y's. So a vector who starts at 0, 0 essentially. So if your head is 3, negative 4, and the tail is negative 5, negative 1, component form says subtract the x's. Second x minus the first x. Negative 5 minus 3 is negative 8. Take the second y, negative 1 minus the first y, negative 4. Becomes a plus 4. Negative 1 plus 4 is 3. So you have the point, or the coordinate, the vector negative 8 comma 3. So if the vector p, if pq, its head is at the point 3, negative 4, and q is at negative 5 comma negative 1. If you take a look at the component form says from 0, 0, go left, horizontal component negative 8, and go vertical component 3. So if you look at this vector, if I drew it to scale, this vector would be parallel to this vector. So it would be a vector in the same direction as PQ, and it will have the same magnitude as PQ. Okay, we face in the same direction, we parallel. So component form is pretty nice because if you're looking for the magnitude of the components, then the difference in x is negative 8, the difference in y is 3. So negative 8 squared is 64 plus y squared, 3 squared is 9. So that's square root of 73. So the magnitude of this vector, it'll be the square root of this, it'll be square root of 73. It's a lot easier to compute values if you're in component form. Again, component form means a horizontal component and a vertical component, meaning that the head of the vector is in the middle. It's in the origin. It's at 0, 0. Because component form is much nicer, we're going to use components. We're going to say, let it be A. Honestly, it's probably easier to use A and B, but I'm going to use A1, B1 here. And I think that might be what the textbook has. I'm not too sure, but I think I might have followed it to a T. But even if you just use A and B, whatever letters you use to choose to be the horizontal and vertical components. So if A1, B1 represents a component form, A1 is essentially how far to the right or left from 0, 0, and B1 is how high up or down from 0, 0. So the components, A1, B1, to find the magnitude, you just take the horizontal plus the vertical component, A1 squared plus B1 squared. To find the direction, essentially where it's facing, what angle, what direction. Tangent of theta, remember, is opposite over adjacent, so B1 over A1. So if you're looking for straight up magnitude and direction, magnitude is like just the first number squared plus second number squared instead of a square root. So that's 169 instead of a root, which is perfect square, which is 13. Tangent of theta is 12 over 5. So when you put this into your calculator, tan inverse of 12 over 5 is 67.4. That is a direction. Now, the idea here, okay, we're going to be careful here. Where theta is between 0 and 360. Could be 0, but not 360, essentially. You want the positive angle. So when your calculator gets 67.4, you make sure at 5, 12, yeah, that makes sure that you're 67 degrees. You're good. That's your degree. That's your direction. That's your theta. Then, if the vector is negative 3, 2 in component form, take the negative 3 squared is 9, take the 2 squared is 4. Square root of that, square root of 9 plus 4 is the square root of 13. That's the magnitude. The tangent of theta gives you the angle. So tangent of theta is 2 over square root of 2 over negative 3. So theta is tan inverse of negative 2/3. You put into your calculator, you get 33.7 negative. So keep in mind that this vector is negative 3, 2. It's in the second quadrant. But you calculated negative 33.7. So when you're in quadrant 2, you have to add 180 to your answer. So plus 180 gives you 146.3. So 146.3 is a direction, not negative 33.7. So I want to make sure that's clear. Vector V is negative 8, negative 4, so you're in quadrant 3. Negative 8 squared plus negative 4 squared gives you 64 plus 16 is 80. 80 is 16 times 5. 16 is square root of 16 is 4. 4 square root of 5. It's the magnitude. Tangent would be the B1 over A1, which is negative 4 divided by negative 8, which is a half. Tan inverse of a half is 26 degrees. 26.6 is over here in the first quadrant, though. So when you're in the third quadrant, you have to add 180. When you're in the second quadrant, you have to add 180. And now when you're here, the point 1 comma negative 3. So you're in the fourth quadrant. You add 1 plus the square root of negative 3 squared. So 1 squared is 1. Square root of 3 squared is 3. So 1 plus 3 is 4. Square root of 4 is 2. Tangent of theta, therefore, is B1 over A1, or vertical divided by horizontal. That's negative square root of 3 over 1. So tan inverse of negative square root of 3 is negative 60. Again, that gives you this negative angle. You want the positive version. You're in quadrant 4, you add 360. So in quadrant 4, add 360 to your answer. In quadrant 3 and quadrant 2, add 180. When you're in quadrant 1, don't worry about adding anything. It gets your answer. And so your answer is 300 degrees. And that is a direction. It faces down and to the right. So that's pretty much just calculation, just kind of formula, that kind of thing. Continuing on, we talk about what's called a unit vector. A unit vector is a vector in which the magnitude is 1. In other words, from head to tail, the distance is 1. So take a look at the 3/5, 4/5. In component form, if I take, again, this u vector represents 3/5, 4/5. I take 3/5 squared plus 4/5 squared is 9 over 25 plus 16 over 25, which is 25 over 25 or 1. So this is a unit vector. I could also take the vector 0, 1, 1, 0, negative 1, 0, 0, negative 1. Those are also all unit vectors. So note if the vector is the point 3,4 or is a component form 3,4, the vector 3,4. If you take the magnitude of it, its magnitude is going to be 5. So if I take 3 over 5 and 4 over 5, that's the vector here. So to get a unit vector, I would take a vector and I would divide it by its magnitude. So if we calculate any vector over its magnitude, assuming this magnitude is not 0, you can't divide it by 0. Any vector that's not 0, you divide it by its magnitude, you'll have a unit vector in the same direction. So how do you find a unit vector in the same direction as a given vector? You take the magnitude of it and divide the vector by the magnitude. So if we would be a unit vector this would be a unit vector in the direction of v. In fact, to find a unit vector in the direction of any non-zero vector, we divide v by magnitude of v. So if we want a unit vector in the direction of v, little v there, a unit vector in the direction of v, we take the non-zero vector divided by its magnitude. Again, that's what it means not to be the zero vector, not to be 0, 0. So find the unit vector in the direction of the given vector, what it says here. So very simply, find the magnitude. Find the magnitude and divide each coordinate by that number. So divide each one by 13. So 5 over 13 comma negative 12 over 13 will be a unit vector in the direction of 5, negative 12. This one, same thing. Find its magnitude. Its magnitude will be the square root of 29. So take each number, each component, and divide by square root of 29. But you can't have square roots in the bottom, so you multiply the top and the bottom by square root of 29, and you get this result. So this is how you find a unit vector in the direction of a given vector v. You take the vector, you divide by its magnitude. And now continuing on. You use a directional vector, a directional angle, to find the component form. So if you're in the world of vectors, and you have an A component and a B component, again, here's your sine and cosine again. So cosine of theta would be A over the magnitude. So where if you multiply both sides with the magnitude, A is the magnitude times the cosine of the angle of the vector of the direction. And same thing for y, or same thing for the B component. The B component would be the magnitude times sine of the angle. So therefore, any vector can be written in this form: magnitude times cosine of theta, magnitude times sine theta. So if you have the magnitude and you have the direction, you can write the component form of any vector. So how do I write component form? Because v is given at the magnitude is given as 20 and theta is given as 45. So you take 20 cosine of 45, comma 20 sine of 45. Cosine of sine of 45 is square root of 2 over 2. So 2 goes into 20 both times 10. 10 square root of 2, comma 10 square root of 2. And that is a vector here that's essentially in the same direction as this vector here. So the given vector you're looking for, it tells you, look, the magnitude has to be 20 and it has to be going in this direction. What components get me there? Well, this was 2. 14.1, comma 14.1. That's the component. In this one, 15 cosine of 218, 15 sine of 218. Using decimals, negative 11.8, comma negative 9.2. A kickboxer kicks a bag at an angle of 30 degrees with a force of 200 newtons. So force is the idea of a magnitude. Write the force vector F in component form. F is the vector, what? 200 newtons going in the angle 30 degrees. Cosine of 30 is the square root of 3 over 2. Sine of 30 is 1/2. Let's cancel. You have 100, comma, square root of 3. And essentially 200 divided by 2 is 100. So 17.3, comma 100. This is the component form of the force that you're given. The 200 newtons at an angle of 30. Those are your components to get there. Number 4. A force of 100 pounds, again, magnitude, is applied to a book. On the ceiling at an angle of 45 degrees with the horizontal. So you're applying some kind of force in this direction, 45 degrees with the horizontal. You want to know what are the components of that force. So you're down here. And so if this is 45, your direction is 315. So 315 and your 100 cosine of 315, 100 sine of 315. Cosine of 315 is square root of 2 over 2. Sine is negative square root of 2 over 2. So 50 square root of 2, comma, negative square root of 50, negative 50 square root of 2. That's 50 square root of 2, comma, negative 50 square root of 2, which is 70.7 in this direction, negative 70.7 going down. To the right, 70.7 going down, negative 70.7. Those are your components of the vector with that force. Vectors is kind of a long section, but they're very short. It's very short problems. So I'm going to walk you through all of this. All of this is the idea of adding, subtracting, and multiplying matrices, and the idea of how to find the angle between two matrices. So if you take a1 comma b1 and a2 comma b2, these two vectors, and k is some real number which we call a scalar. To add vectors, you add a1 and b1, a1 and a2, comma b1 and b2. So you add the horizontal components, you subtract, you add the vertical components. Subtraction, you take a1 minus a2, comma b1 minus b2. You subtract the components. To multiply by a scalar, you multiply the number to each component. To do the dot product, you multiply the first number of each, the horizontal component, then you multiply the second number of each, the vertical components. So you multiply each component, each of the horizontal, each of the vertical, and you add the answer. That is what's called a dot product. Now here, to find the angle that lives between two vectors, you find the dot product of those two vectors and divide by the product of the vectors. Let me walk you through this. Sounds like a lot here, but it's not bad. So let V be the vector 3, 5, and let W be the vector negative 4, 6. Find V plus W. V plus W would be 3 plus negative 4, and then comma 5 plus 6. 3 plus negative 4 is negative 1. 5 plus 6 is 11. That's it. Just add the horizontal components, add the vertical components, and get a new vector. Subtraction. Subtract horizontal components. 3 minus negative 4, comma 5 minus 6. 7, comma negative 1. That's it, and that's all. This one, multiply by a scalar. So this is actually magnifying the force. This was actually in the force. So multiply each vector, each component here in vector v by 3. So it's like 3 times 5. That's just 9, comma 15, and that's it. That's all she wrote. And the next one, 2v plus 3w. Multiply 2 to the components here in this vector. So 2 times 3, 2 times 5 is 6, comma 10. And then 3, the y, the w component, w vector, you get negative 12, comma 18. So then you add the two components, vectors. So first of all, you distribute each number into each vector, and you add the vectors first plus first, second plus second. So you get negative 6, comma 28. Dot product. Take the first number of each and multiply. So 4 times negative 3, negative 3 times negative 4 is negative 12. And the second number of each, 5 times 6. That's 30. So negative 12 plus 30 is 18. And that's all it's asking. Just find the dot product. The angle between them. The angle between them is the dot product divided by the product of the magnitude. Well, the dot product we did already in the previous one. So to find the magnitude of each, again, 3 squared plus 5 squared instead of the square root, negative 4 squared plus 6 squared instead of the square root. You get the square root of 52 and you get the square root of 34. Those are your magnitudes. So cosine of theta is 18, which is the magnitude, the dot product divided by the magnitude. Now, when you put all this into your calculator, you get 64.7 degrees. So let me see, make sure you're back in degrees. So second cosine of parentheses 18 divided by, I'm gonna do like this. Put the two of them together. Square root of 18, 34 times the second square root of 52. I'm putting 3 here because I'm closing essentially the root. The second one is closing this parenthesis of it. 18 square root. Okay, the first one closes the 52. The second one closes this parentheses, and the third one closes. Yeah, there you go. Oh no, it isn't. Plus, I didn't put multiply. There you go. That's the problem. Okay, sorry about that. So second cosine, 18 divided by parentheses. What? Square root. Square root of 34, close parentheses, times second square root 52. Close the 52, close the bottom, close the whole thing. There we go. $64.7 roughly. Más o menos. So that's the angle between those two. And that's ultimately how this works. It's just straight up formula. It's not that hard. I know it's easy for me to say because I've done this a long time, but take two other vectors, 2v plus 3w. We're going to multiply each number here by 2, so that's going to be 10 comma 12. We're going to multiply each number here by 3, so that's negative 18 comma 15. Then we're going to add 10 to negative 18, which is negative 8. 12 plus 15, we get 27. That's all it is. Here we're going to take 4 times the first vector. 4 times 5 is 20. 4 times 6 is 24. So 20, 24. Now I know it says negative. I know there's like a negative 2, which is fine. I actually just say take the multiplication by 2. 2 times negative 6 is negative 12. 2 times 5 is 10. Now leave the minus outside, so you just subtract. Use the rule for subtraction. 20 minus 12 is 8. 24 minus 10 is 14. The angle between V and W. V dot W is actually 5 times negative 6, which is negative 30, and then 6 times 5, which is 30, added up, which is 0. Here are the magnitudes for each of them, 61 and 61. But no matter what the bottom is, the top's always 0. The top's 0 here, so cosine of 0. So if you take cosine inverse of 0, you're going to get 90 degrees. So if the answer is 90 degrees, it means that two guys make a right angle, which means instead of calling them perpendicular, for lines and rays and line segments and that kind of stuff. For vectors, we call it orthogonal because you can be out in space. You know, you can do three-dimensional later on and so on and so forth. But right now, we call them orthogonal, which is a fancy way of saying perpendicular. One more here. Find the angle between two vectors. Here, I find the dot product. 2 times 6 is 12. 15 times 5 is 75, so that's 87. The magnitude of V is 4 plus 25, square root of 29. Here is 36 plus 225 is 261. So if I take 87 and I divide it by this mess, by 29 square root of 61, what it turns out to be is that this is actually 1. If you multiply the square root of 29 times the square root of 261, you're going to actually get 87, essentially. And then so this actually is the cosine inverse of 1, which essentially leads you to 0. So if the angle between them is 0, they're said to be parallel. In other words, they're on top of each other. There's no angle between them. They're the same vector. They're parallel. They run next to each other. So parallel and orthogonal. So if theta is 0, they're parallel. If theta is, 90? They're perpendicular, or we call it orthogonal. Geometrically speaking, you take two vectors. If I may here, you take two vectors, and here is V and W. What you normally do is you can slide them. So I'm going to slide W this way, parallel, and just slide them over, where the head of W is at the tail of the tail of V. So then you connect from where you start all the way to the end of that path. So here, that path, that's V plus W. So you slide them over and then add it. Subtraction, instead of taking this guy and sliding over, I'm going to take its opposite direction. I'm going to take its negative. I'm going to go the other way. I'm going to go this way. And I'm going to slide this guy over there. So take its opposite, then slide this guy, and then add. So that's v minus w. The scalar would be multiplied times the vector. So if it's like a double or 3 times or 4 times, it gets bigger and bigger. If it's less than 1, it's a smaller. So it just scales along the same vector. There's another notation, what's called INJ notation. INJ, see if I can butcher this. I is the vector 1, 0, and j is the vector 0, 1. So if you have, I don't know, vector like negative 3, 5, it's like saying 3 times I plus 5 times j, or something like that sort. So the I vector is a unit vector in the positive x, 1, 0, and 0, 1 is the j vector. So if you have a vector 2, 3, it's like saying 2 belongs to the I part and j belongs to the y part. So I and j is another way of saying x and y. So 2i plus 3j means 2i, and 3j means essentially 2 to the right, 3i. And that's your vector. 2i plus 3j. So it's the same thing as the vector 2, 3. Negative 3, 5 is the vector negative 3i plus 5j. So just a way of writing it. Negative 3i plus 5j. So instead of putting it in this form, we put I and j instead. So if I want to take two vectors in I and j, I'm going to add the I parts. So 4i plus 5i is 9i, and 3i minus 2j is just j. So that's going to be your ij form, which is 9, 1 in component form. Here, if you multiply 2 times the v vector, 2 times the I, 2 times the j, and then 8i plus 6j. So the component form 8, 6 and 8i plus 6j say the same thing. It's a different way of saying it. Okay, so this any component is the same thing as having that guy I plus this guy j. I horizontal, j vertical. So some books have a little house top here, or a little tiny little vector on top of I. I'm not going to do that. Just think about it as I is the horizontal and j is the vertical. And that's essentially the notation. And that's pretty much what goes on with vectors. It's kind of a lot of information, but it's a lot of notation, really. And then ultimately, we do some word problems here. Now, a lot of these are just kind of, can you keep something from falling? So if you're on an inclined plane, there is a force going down, straight down. It's the weight of that object, which is the force due to gravity. It's the weight keeping us down. It's our weight, it's our force of gravity. And there is a force that's perpendicular to the inclined plane. It's what's called the normal force or the norm force. And there's a force required to keep this thing from falling. So that is Fr. It's parallel down here. So that's what it looks like. As it works out, this incline and this angle are the same thing. This would make a right angle because it's parallel to this guy, which is also a right angle here with the force of due to the normal force. So when you look here, these are going to be the same answer. When you try to find the missing part here, you're trying to find the missing part of a right triangle, which is not that difficult. So if a car weighing 2,000 pounds is on an incline of 8 degrees, how much force is required to keep the car on the incline? This is a right angle. The car weighs 2,000 pounds, so that's the force going down. That is the force due to gravity. It's an incline of 8 degrees, so if this is 8 degrees, that's 8 degrees. What is the force required to keep it up on the incline? This one. So we're in a right triangle. We have this angle and we have this hypotenuse, and we're trying to figure out this answer. So we have opposite and hypotenuse involved here. So we have sine. Sine of 8 degrees, therefore, would be the normal force, the magnitude of the normal force, sorry, the magnitude of the required force divided by 2,000. We multiply both sides by 2,000, and 2,000 times sine of 8 is really the magnitude. That's what we're looking for. So that comes out to be 278 pounds, roughly. That's all it is. And number two, if a force of 500 pounds is required to keep an object at a 10% on a 10% incline, how much does the object weigh? Well, we're looking this time for the force due to gravity. So if this angle is 10 and this length is 500, then this is your hypotenuse. So the sine is opposite over hypotenuse. So we're looking for what? 500 divided by the magnitude of the force. Multiply both sides by the magnitude of the force, and then divide both sides by sine of 10. So the magnitude of that force is 500 divided by sine of 10 degrees. And then when you plug that into your calculator, that's 2,879 pounds. 79.4 pounds. And this is the conclusion of chapter 7 and vectors. Polar equations, vectors, and what have you.